Okay, so in the 1970s, scientists took 25,000 neurons from a rat's brain, they put it in a petri dish and studied it, and realised that these neurons started to form their own neural network independently. They were able to attach these to a cell device, and it was able to be hooked up independently to a flight control simulation program, and the thing was able to actually fly a plane. They then hooked up the rat, and they were able to map the rat's brain and its different activity as it moved about. So as it moved left, it had a different pattern to when it moved right. They then later moved on to monkeys, and they hooked up the device. It's called a brain-computer interface to a monkey, and the monkey had to move with a joystick, a little thing around a screen. So it's moving it, and the brain-computer interface was able to translate this movement into movement in a robotic arm in another room. The monkey couldn't see anything at this stage, but later developments, what they realised was they could actually have the robotic arm in the room, and the monkey was able to look at it, and it realised after a while it didn't actually need to move the joystick at all. It could just think about moving it, and the robotic arm would move, and it was able to, with thought alone, just move this thing. So this is really incredible technology. So things that we've done recently, we've hooked this up to humans, and with an MRI scan we're able to study people looking at a 10 by 10 pixel grid with different shapes on it, and it shows up different patterns of neural activity, and looking at the different shapes will show different patterns for each shape, and we're able to actually see into the mind's eye. Down the bottom is what we're actually seeing. That's an actual look into the mind's eye. A company called Neurovigil have created something called the eye brain, and it's able to capture higher resolution images than these 10 by 10 pixel images. And they're hoping in the future to be able to do colour images and even moving images. And they want to actually be able to, within 5 years, record your dreams. This is straight up. They've developed a smaller version of the eye brain, which they're hoping the motorists will be able to use, attached to your head, and it'll be able to detect if you fall asleep. And we'll let the car act accordingly, and we'll sort of save you from that. And they're hoping that one day you won't need a head strap at all. You'll be able to just scan the brain directly. Toyota have brought out the world's first brain-powered wheelchair. So people who are paraplegic, quadriplegic, severe disabilities will be able to move their wheelchair without a joystick. They'll be able to just think about the action of moving a joystick, and it will move the thing. And these things have a reaction time of about 125 milliseconds, which is almost as fast as you think. This guy lost both of his arms in an electrical accident when he was 18, and he's had prosthetic limbs attached to the nerve endings where his arms are amputated. And he's able to control these limbs with thought power, with his brain. And he's just been in the press for being the first person to drive a car with prosthetic limbs. Honda have a robot called Asimo, and they recently hooked him up to a BCI, brain-computer interface, and they're able to control Asimo with thought power. They're able to control his arm movements, hand movements, stick out his tongue, make him walk. Just the thought of these movements are able to be translated into actual movement by the robot. We're starting to see this in day-to-day things. Mattel have just brought out a brain training toy. It's a head strap that measures concentration levels. And the more that you concentrate, the more a fan moves, and it makes a ball move. And you have to move this thing around. It's similar to the thing we got, Jimmy. Yeah, exactly. You're able to move this around. Star Wars brain training toy. So we're starting to see this in everyday life. The Arduino makes it possible for us to actually hack into these devices. So we could grab one of these headsets, and we can actually use it for a project. We can actually hack into this. There's even an API for one of these headsets as well. So we can start thinking about ways of using this right now. I have to talk really fast. Where we're really going to see these developments take off is in gaming. A company called Emotive have brought out a headset that detects not only unconscious thoughts like that, but also it detects facial expressions, it detects non-conscious thought, so your avatar in your game will actually be able to react as you're reacting to something in real time. So they've brought out, Hitachi have brought out a prototype version of a remote control that's thought powered. They've successfully managed to turn things on and off around the house, like an air conditioning unit. And the headset measures changes in blood flow in the brain. So all you have to do is just think very slightly, concentrate, and you can affect these things. We're starting to see this in the mobile industry as well. a company has brought out a Bluetooth headset which detects these kind of brain changes. So your phone rings and you're able to actually answer it just by thought alone. They're actually hoping that one day you'll be able to think about texting. You'll be able to text thinking about words. Whether that's a good thing or not is another thing. Twitter, this guy, Adam Wilson, University of Wisconsin, he's developed a system where letters flash up on screen, and when the right letter appears, he thinks about it, eventually creating words and eventually sentences. When he's happy, he says, yeah, and off it goes to Twitter. Thought Power Twitter's here. Dave, you'll be happy.
I'm doing it.
So the Department of Homeland Security is really interested in this. They're testing a system that actually scans people's temperature, differences in your facial movements, and it's detecting. It's a system that will detect for terrorist threats, basically. It's another company that are hoping to be able to scan your brain, your actual brain stem. And what they do, they test your brain for auditory stimulus, and they match the response of your brain to the file they have on record, and they're able to match your identity. So, just no more eye scans, it's straight into the brain stem scan. The US Army have got a $4 million contract out for a project called Silent Talk, which is helmets that soldiers can wear, and they'll be able to communicate silently between each other just by thinking about words. It's telepathic. This is actually happening. As we speak, they're hoping they'll be able to control military things with this as well. So, and in marketing as well, neuromarketing is the new field. There's a blind Coke Pepsi test where they had subjects drinking Coke and Pepsi, and about 50-50 part of the brain lit up, which was the reward centre of the brain. When they were told which one they'd actually been drinking, 3/4 found there was a different part of the brain where 3/4 of them had that part lit up. So proving that it's very important for us to understand this. That's it.